Good evening, everybody. I'm Sylvia Richardson, the president of the Royal Statistical Society, and it's my great privilege to welcome you all, fellows of the RSS, guests, and our very special guest, Andrew Ang, to this evening event. With the cold spell in the UK, we are all in need indeed of a fireside chat. This event has been organized by the Royal Statistical Society Data Science Section, which was created in 2017 to represent professional interests of data scientists. The section is chaired by Martin Goodson, who is himself CEO of the AI startup Evolution AI, and he will be helped with respect to the questions and organizing the Q&A by James Weatherall and Giuseppe Papalo, who are also members of the data science section. So in a few moments, I will hand over the chair to Martin. Now, just to give you a little bit of background, this year's program of the data science section is focused on organizing a series of events on leadership in data science and AI. And tonight is the first in this series. And we're very much indebted to Andrew for having accepted our invitation to join us from California and launch this Fireside Chat series to such a good start. We've had more than 1,000 registrations to this event. I'm sure that all of you know Andrew as founder of Deep Learning AI, chairman and co-founder of Coursera, and currently adjunct professor of computer science at Stanford University. Andrew has been one of the most important drivers behind the success of deep learning over the last decade. And in particular, he founded and led the Google Brain project, which developed massive scale deep learning algorithm. I could say a lot more, but I'm sure that you are impatient to hear directly from Andrew. So I will stop now and hand over the chair to Martin.
Thank you, Sylvia. And thank you, Andrew. Thanks for coming to talk to us about leadership in AI. Maybe we could start off by you bringing us up to date on how you're spending your time at Deep Learning AI, Landing AI, and the AI Fund right now.
Sure. So it's a pleasure to be here. And some of you know that I am from the UK. I was born in London many years ago. Having had the pleasure of visiting London for almost 2 years now, where I was last in town for the Coursera Partners Conference we held at the University of London, I think back in 2019, but hopefully when the pandemic lifts, I'll have an opportunity to visit again. So to answer your question, Martin, when a few years ago, I felt that for AI to reach its full potential, we need a few different things. And so over the past few years, I've been building an ecosystem of teams, including Deep Learning.ai, AI Fund, and Landing AI, to try to build some of these pieces to hopefully help AI reach its full potential. Deep Learning.ai is our educational arm. I and other instructors continue to teach courses, often usually hosted by Coursera, to help individuals advance their careers. AI Fund is a venture fund where the team works hard to back entrepreneurs, create valuable AI companies that can move the world forward. The rise of AI technologies creates a lot of opportunities for new companies to be built. And so AI Fund focuses on supporting entrepreneurs to do that. And Landing AI is a B2B company that helps enterprises jumpstart adoption. A lot of larger legacy enterprises, anything from e-commerce, retail, to agriculture companies, to manufacturing companies, where AI adoption is still really hard and can create a lot of value. So Landing AI has been doing that.
Thanks, Andrew. So, I mean, it's really nice to hear that you're supporting startups putting out AI products with the AI Fund. This is, AI product design is a subject that's really close to my heart. I'm really interested in the role of process in AI product design. So I want to ask you whether you have a fixed process that you follow, or really is it kind of a loose process that you follow? For example, do you start alone, or do you start with a small team when you're starting a project? How do you look at this?
Yeah, so, just a few things I've learned about building AI products. When I speak with, say, business leaders in a B2B setting, I've learned to just say up front, I should go to people and say, don't tell me about your AI problems. I don't hear about your AI problems. I don't hear about your business problems. And it is my job to help figure out whether or not there is an AI solution to it. And sometimes there isn't, and that's fine. And then I think I feel like the world is so diverse. Good ideas come from all sorts of places. I've had friends come to me with, just personal things like health and wellness, or can build an AI product to support an individual's health and wellness goal, and that can lead to product ideas for B2C products, or for B2B settings. Well, really, when we talk to executives in large companies, when we see a common pain point, then that's when we start to think, maybe there's a product to be built that can serve multiple customers. So, for example, in the work that we do on automatic visual inspection, many manufacturing companies were trying to use modern deep learning in order to build a system that can check, if a smartphone you manufactured, or a semiconductor wafer you just manufactured, or a large sheet of metal you just manufactured, if that has a defect, such as a scratch or a dent or a wrinkle in it. And many of the manufacturing companies we're talking to, were saying that it was really difficult to build and maintain these AI systems. Deep learning works great in theory, and you can do well in the test set, maybe, but all the practical realities of making that actually work well in a production environment turned out to be really difficult and really expensive to maintain. So we wanted building a product, kind of an ML ops platform, to support manufacturing companies to do this work. So that's one example where talking to multiple customers allowed us to discover a need, and then my team actually one of my teammates, wasn't even me, Kai Yang, created a lot of vision of the product that we then built, and seems valuable to many companies now. So maybe to answer your question, I think it's a little bit of a loose process. As a technical person, I think all of us have this wonderful hammer called machine learning or data science or statistics. But I tend now, as I get older, to emphasize more starting from the business problem and understanding that first, and then only later figuring out if this wonderful hammer that we have is useful at all for their problem.
And then, so when you get started with the algorithms, so after you've discovered what the business problem is and you start to get to work on the algorithms, are you then working with a team right from the beginning, or are you focusing on this yourself?
It depends. I think, I often work with others as soon as possible. Unless, I guess, I can only lead so many projects myself, right? There are a few projects I'm sad about that I want to lead them personally. But for the most part, I feel like what excites me the most is, finding partners and supporting others and supporting my partners to make them more successful. Because I think it's by doing that, one of the things about building products is it does take someone obsessively thinking about it for many hours, for weeks, to have those deep insights. Maybe when I was designing the early versions of the Coursera product years ago, I spent years in my spare time thinking about online education. Should the videos be 10 minutes long or 5 minutes long? Or should we have auto-graded quizzes or not? And a lot of ideas that did not work out anywhere that you probably wouldn't have heard of. Should we have multiple people sitting in front of a computer? That turned out not to be as useful. And it took many, many hours, really over a span of many years, in my case, to flush through all those details and run experiments. And so I think that early stage products and early stage companies often succeed or fail by the strength of the one or two or three heroes and heroines, the founders of the product or the founders of the company, that will flush through all those details. And I think unless I'm personally leading something myself and have the time to dedicate into it, I find that the project set up better for success if I'm just a partner to someone else that wants to do that, do that very detailed, deep thinking.
So there needs to be a small core team who are doing that deep thinking, and then maybe having a wider team around them.
Yeah. Right. So I find that so maybe at AI Fund, one thing we often do is if there's an idea or sector that founding team is excited about, they come and speak with us about it. And if we're excited about it, we might decide to back them. But then we can also surround that core team with engineering resources. So they need engineering prototype build. We have engineers that can help them, right? Spend a few days to build a prototype while they keep on doing the hard work of thinking through what exactly is the product. One of the things about building a new product, building a company or product or business, is there's so many cross-functional diverse skills needed, right? And sometimes you just need a 30-minute conversation with someone that understands how to do the marketing, or you just need a 1-hour conversation with someone that really understands zero-shot learning and can this NLP thing work on. This actually happened with one of AI Fund's companies. The CEO had a great idea, but our engineer was able to work with him to figure out that, yes, we could actually do zero-shot learning for this application. And our engineer built a prototype, gave it to the CEO. So the CEO seemed very happy. But now they have this new way of using zero-shot learning to draw inferences from really no data at all that looks like it could be a core part of this company's product. So the problem is building a company requires very cross-functional skills, right? You need to figure out the tech, the business model, the marketing, operations, and sometimes a half-hour conversation with someone that's domain expert helps move the company forward.
Okay, so you're staying on the topic of the leader or the small core leadership team of people who are really focused on the product. I read an interview with this guy called Gordon Murray, who's an industrial designer, actually. He's the guy who transformed Formula One in the 80s. He completely changed the design of the cars, the pit stops, everything. And then he went on to design the McLaren F1 car. But something he said that struck me, he said, well, first of all, he said that the team had to work incredibly intensely. They really had to work hard to achieve this stuff. He said he had to walk a fine line between dictator and democrat, which I thought was really interesting. And you really got the sense that he actually was totally on the side of being a dictator. He was totally on the side of being a dictator on that line. What do you think about that? Like, how does the leader or the small leadership team, as you've outlined, how do they make sure that they're capitalizing on the rest of the creativity of the team, or that you're really bringing out the best ideas and not just having it dominated by one or small group of people?
It's tough, right? I think that when you're making decisions, we're always operating in the fog of war. You just don't know what's the right decision. So I think for myself, if is a sector where I think I have deep expertise, if there's a problem I've worked on for years, I know I've thought about it for years, and I've read the papers, I think I know what I'm doing, then I'm very willing to just make a decision and say, hey, everyone, I know you have a different opinion, but I'd like you to just take a crack at this with me and trust me on this, and let's just take a crack at it. There's a phrase that Jeff Bezos uses that I stole from him, which is, please take a gamble with me, right? Let's just try that. We'll see the world. So when there's a sector that I think I have domain expertise, then I will, kind of politely insist on, let's just try it this way. But most of the time, the leader hasn't spent nearly as much time thinking about the issues as someone else. And if someone else has clearly thought longer about an algorithm or concept or something, then I think hopefully the leader is smart enough to realize that someone else is smarter than you on that problem and to do it their way. I would say one of the challenges I keep running into in AI specifically is that because the AI machine learning industry is so new, a lot of the processes have not yet been fleshed out, right? And so it often takes someone with both technical judgment and business judgment in order to make the best decision for what to build and what not to build. And unfortunately, in today's world, it's very difficult to find individuals that understand that whole picture. Is this tech going to work? Well, you need to be pretty tech to know that. Is this product going to work for the user? Well, you need someone with some customer empathy, product sense to know that. And can this actually be a valuable business? Did the economics of it work out? Well, you need someone with some business experience to do that. And so sometimes you find someone with deep expertise in one of these sectors, someone that's deeply technical, which is wonderful. We need more people like that. But if the decision to launch a product is based just on one of these three pillars, then that often doesn't lead to the right decision. So try to take that into account as well. Sometimes there'll be someone that maybe understands a certain algorithm better than I do, but if I don't think they understand the product or the business aspects or something, then I might still talk to them, try to explain to them the other issues, and try to make a better decision together.
Yeah. That brings me to my next question, actually. Though I wanted to ask you, how technical should the leader be? I think it's a real shame that in many AI or machine learning teams in industry, especially in corporates, large corporates, often the leader is not someone with a scientific or engineering background at all. If anyone's been to our other events, they're probably bored of me saying this, but I don't think that's the best way. But how technical should the leader be? I mean, should they be reading papers and coding all day, or how do you get that balance right?
Yeah, so the framework I often use for all sorts of roles, even even if you're, I don't know, even if you're a board member putting in place a CEO, or if you're a citizen electing someone to a position in government, right, all the way to hiring someone for a specific role. The question I often ask myself as a team is, what does this person need to know in order to do their job? And so for a general manager of a large project, maybe they don't need to know how to code to do their job. Now, we could wish they knew how to code, just as we could wish they also could do sophisticated financial modeling and that they could draw wireframes and do product design. Right? It turns out I can draw really bad wireframes, but you don't want me doing that. So I'm sure some of my product managers wish I was better at product design, because I'm really bad at visual design. I think I have just no sense. I'm so bad at it. This is why my house is decorated with a picture of the world now. I just don't know how to design visual stuff. Right? So I think we all wish we were all stronger in different things. I think that for the leader of a project, it's nice if they have enough of a sense to have a feel for what AI can and cannot do, and then to know when to get out of the way of the technical team. And I find that leaders that don't have a sense of what AI can and cannot do sometimes have a harder time managing highly technical teams, because how do you set the direction and set the goal if you don't know, is this even doable or not? And so I've seen leaders, unfortunately, read the news. Actually, there was once a team I spoke with where CEO of the company was asking us if we could build a self-driving car with 6 engineers in about a year. And I kind of said, no, I don't think I know how to do that. But if that person had asked his team to build a self-driving car with 6 engineers for a year, that team would have been set up, really not set up for success. So I think leaders need sufficient technical judgment to set direction and milestones and allocate the resources to the teams, I think.
Yeah, actually, so our company, Evolution AI, we had a project with a big corporate. We sat down and for the kickoff meeting, and the leader of the project on the other side, he said, what we're really excited about this project, because the great thing about AI is that it never makes any mistakes. And we just started laughing because we thought it was a joke, but then we gradually realized he wasn't joking. He really thought that. But anyway, so let's move on to the next topic. Another balancing act I'd like to talk about is the balance between doing, really kind of creative, high risk R&D, and doing what you think is probably going to work. It's a bit boring and it's going to give good enough results, but it's probably not going to push anything forwards in terms of technology. How do you get that right?
I think, this has been, I think it depends on the organization, actually. If the main goal is to be a research organization, then a lot of bottom-up, curiosity-driven research makes sense. And there, if the goal of the organization is to publish multiple fantastic academic papers that moves the thinking of the world forward, then I think that's a great way to do it. And this is why we tend to run universities this way, right? Every research group, usually led by a professor, does their own thing, tons of creativity, and then the peer reviewing system helps enforce a relatively high standard in the papers published. Some corporate research labs have that goal as well. We say, let's do lots of research and see what papers come out of it. And I think that's great, and that's to be celebrated. When I'm building a product in a business team, then I think the teams I lead tend to be much more focused, where we try to, I think there are enough ideas for projects where the dotted line to a business impact or to a customer impact is clear enough that I would often spend more of our time on that work. Let me just say one thing though. I find that for most of my life, there have been projects I'm excited about and working hard on. So I'm really thinking a lot about those projects, such as an AI fund, trying to build specific companies, deep learned AI, trying to create more educational content and help more people build a career in AI, or land AI, the manufacturing vision inspection, some things in econ. So there's some projects where I can see the path to a significant impact to help a lot of people. So really working on that. For almost all my life, I've also spent some of my spare time just poking around at other random fun ideas. And so, I don't know, actually, yeah, over the weekend, well, I happened to be reading. Yeah, so actually over the weekend I was reading this paper. I'm not endorsing it, I'm still reading it, trying to decide. It has some ideas for improving it, So in my spare time, I tend to read and look at a lot of things broadly with no expectation they'll ever have any impact, but I find it intellectually fun and exciting. This is one of the things I've learned as well. It is really difficult to be good at something unless you find it intellectually exciting. So when I don't know, I think all of us have this experience, right? When when I was younger, even doing my PhD, I just did it because it was fun, and I wanted an autonomous helicopter to fly using reinforcement learning. So I stayed up late. Probably I shouldn't have done that. Should get enough sleep. But I actually stayed up late many days, which I don't recommend. So do get enough sleep. Like just because I was intellectually curious, I want to figure it out. And when building Coursera, again, I just did it because I wanted it to work. And also it was fun, and I was intellectually curious if I could build this and use it to serve learners. And today I find it intellectually fascinating, right? When I'm going out for a walk with my daughter, I guess I'm kind of paying attention to my daughter, but sometimes I'm thinking, all right, can we build a more sophisticated MLOps platform? What's the right labeling tool? And how do we do this with less data? I probably should be a better father now that I'm saying this out loud. But I think we need that intellectual curiosity to then think about all of these ideas. A lot of time it won't lead to any impact, but then that helps sharpen our brains. And for me, a lot of those random things I did in my spare time turned out to be quite useful later. Although a lot of those things I did in my spare time also turned out to be completely useless. But I think that's fine too.
Great. Okay, I'd like to move on to talk a bit about skills. So, just at the top level, what are the critical skills that you think people should be focusing on right now?
The AI world is now diverse and complex that I think there's no longer a one-size-fits-all answer to that. So maybe take software engineering, which is a bit more mature than AI. I think software engineering has fragmented into multiple career tracks, right? So you can be a front-end developer, back-end developer, mobile developer, DevOps. So there are multiple roles with specialized skills, or product manager or something else. And I think AI as well. There are now machine learning engineers, data scientists, business analysts, data engineers, and so on. So actually, Workera, which is a team I've been affiliated with, published actually, I think, a very thoughtful report on some of the roles that AI is fragmenting into. So the individual can look at that and say, oh, I want my career track to be, I want to be a machine learning engineer, or I want to be a software engineer that builds machine learning systems, or I want to do that. And so I think, I think advancing one's career that way, there are now multiple career tracks. One of the hardest things to find in today's, I will say just some gaps in today's world, some things that I think no country, no company has enough of. I want to say one role is the AI architect, which is someone that can look at a business problem, look at an application, and form judgment on what to do and what not to do. This type of role is almost impossible to find. It's so hard to find people that could do this. It's even harder to find this type of AI architect to define a machine learning engineer. But we also don't have enough machine learning engineers, so people should learn that too. And then I feel like there are still.
Sorry to interrupt. The AI architect is someone who has more of a kind of overall vision of the whole system rather than just one small components.
Someone that can. Let me think. So actually, maybe here's so. For example, one thing we've done at Landing AI is speak with e-commerce companies, companies that sell stuff online, and we talk to them about the business problem, and they'll show us, look, they have this data architecture, they have these products, their product catalog looks like this, they have these users, their user data is stored like this, they have this data in-house, they've outsourced this part of the website to other vendors, so the data is stored like that. And so that's just the state of the world today, right? And their goal is to build a more effective website or effective marketing system or something to help users find more relevant products. And so what are you supposed to do? So there are, 50 things we could brainstorm 50 ideas. But so to have the creativity to both brainstorm those 50 ideas, as well as to then assess the 50 ideas to say, of these 50 ideas, yes, we should build a recommender system, and should it be a content-based recommender system, or should it be more, or not, right? And if so, what's the right database architecture to pull in these user IDs to do user ID mapping? So you have two accounts, the same person, put it together. Do you do that or not? And if you do that, it was going to take 2 engineers 3 months. So is that worthwhile, or do you want to prioritize something else? So to sort through all those decisions to arrive at a good conclusion for these are the 2 projects we need to do, and you need 6 engineers for 6 months. And at the end of that, the ROI will be a 5% lift in CTR on this webpage. So to sort through all that requires deep technical judgment, because you need to know these are the algorithms with enough data to make it work, as well as good business judgment. So that type of role is almost impossible to find.
Yeah, I just don't think that really exists yet. One thing I would say is,
and I just want to say one thing I'm passionate about. I think one other thing I'm seeing is I think the AI world, and I feel like this is even partly my fault from the way I've been teaching machine learning, right, for a long time. Which is, I feel like, in academia, we're used to holding the data set fixed. You download the data set benchmark, and then you work on the algorithm to make the algorithm work, right? And this has been great because it's driven tons of academic research progress, where you have a standardized benchmark data set. We all work on the algorithm, and then we do better on the holdout test set. But what I see for a lot of commercial projects is I actually go to my teams and I sometimes say, hey, everyone, the algorithm is good enough, like UNet or ResonNet or whatever, EfficientNet is good enough. So everyone, let's fix the algorithm. I don't want to mess with it. I don't want anyone to mess with the algorithm anymore. We're using EfficientNet. And let's just keep on changing the data until the algorithm's performance is good enough. So we actually see this in manufacturing vision inspection. So you want to input the picture of the phone, see if it's stretched or not. And often we find that the teams, if we just hold the algorithm fixed and work on the data, the team makes faster performance than if we hold the data fixed and work on the algorithm. So I think our field still, we know data is important, but the craft of designing data, we use terms like data cleaning, but I think it should be a very respected and very important engineering discipline to get the data right for your learning algorithm.
Yeah, I think that's kind of a difference between machine learning, which is coming from the computer science tradition, compared to other empirical sciences, which have, most sciences other than have a really long history of observation, experimentation. It's all about data. It's all about who collected what pieces of data. And computer science doesn't really have that. I wonder whether that's partly why there's this kind of natural reluctance to focus so much on the data and have these benchmark data sets that you're just given and you just work on the model. How people can develop these kind of empirical research skills, which are quite common in you go to biology departments or physics departments, and everyone's going to be all about collecting data. Why is it so different, and how can people collect those or gain those skills?
I think one thing I think is useful for a lot of that. I think exploratory data analysis, EDA, is is taught in most statistics curricula. I think this is one skill that many machine learning engineers would benefit from deeper intuitions about as well. And maybe the thing is, if you're a large consumer internet company and you're 1 billion users and 1 billion data records, you just kind of train an end-to-end machine learning algorithm and it works great. But it turns out that outside software consumer internet, the data set sizes are much smaller. I've worked with companies with only several million users, or in manufacturing, we may have only a few hundred images. And if you have only hundreds of images and your data set is small, then the practices and ideas are different. And it's more important to use the data, but also complement that with human intuition and human prior knowledge. So I think building the tools so that human intuition be injected seems to me important for solving a lot of these problems with smaller data sets.
Okay, I want to switch topics a little bit. So, it's pretty clear that one of the really striking successes of your career is how you've opened up the field of machine learning to outsiders. Just on a personal note, I remember reading your papers in 2011, 2012, and just thinking, these papers are really written. Like, I really understand what this paper's about. And there were lots of papers at the time were quite, kind of obfuscated and quite difficult to read and understand, I thought. But, everything that you've done with Coursera has just really opened up, you could sort of say that you drew back the veil on machine learning and really opened it up to a lot of different people, maybe from, non-traditional backgrounds as well, which has really increased diversity in the field. But, this is obviously a great thing. But I want to touch on whether you think there's a place for credentials and formal qualifications, like there is in engineering. If you want to build a bridge, if there's something involved in public safety or ethics, then probably you need some kind of credentials in engineering, traditional like civil engineering. Do you think there's a place for this in AI and machine learning?
I don't know. It's a good question. I think maybe the question is what is the interest of the public in terms of credentialing or not credentialing? We've all seen, actually here in California where I am right now, we're seeing credentialing being used to defend an industry from new entrants. So the credentialing needed for certain industries. It turns out you need to study tons of hours to be a hairdresser, right? In a lot of places in the United States. Yeah. And then so that's become, so there's some industries where credentialing has become more protectionist. I think one challenge of requiring those credentials is that the field is evolving so quickly. And so a standards body that is writing credential, it seems challenging for them to keep up. So I find that when someone earns a certificate from an online course or for an online master's degree or something, those credentials are taken very seriously by employers. I mean, if you list a certificate you've learned, deep learning online, it's definitely a plus to have on someone's resume. But whether to require them for certain roles, that seems unnecessary for many roles in AI right now, where there isn't a safety critical aspect of it. But I think there's actually one thing. I think ethics is an important thing. I don't know that credentialing is the right solution to making AI safer and more ethical. We do want AI to be safer and more ethical, but I think there are other solutions we should consider as well, such as auditing. So when I'm building a AI system where there are safety concerns or fairness concerns, I tend to, well, first, I guess I'm fortunate to work with team members I trust and like and know well. We're a wonderful team. But then we actually try to sit down and brainstorm in advance all the things that could go wrong. We actually adopted processes from it's called FMEA analysis. It's a methodology traditionally used for analysis of hardware failures. Like if you build an airplane, how can an airplane go wrong and crash? So we actually adopt that framework, FMEA analysis, to brainstorm all the ways the machine learning system could go wrong, and then rate them right by detectability, priority, impact, likelihood and impact, and then design metrics, and then try to preemptively come up with solutions or monitor them to try to make sure the bad outcomes don't actually happen. And then we also sometimes audit ourselves, or sometimes with help, double check the performance of an AI system before we let it into the wild. So I think there are other processes we can use to ensure to increase safety and bias. And education is one of them. Mixed feelings about whether credential is the most effective technique at this point in time.
Got it. Thank you. Okay, so I'm just going to ask my last question before we go to the QA and get some questions from the audience. So, it's pretty obvious that governments all over the world have hit upon AI as a way of, boosting their economies, increasing productivity, and so on. So, like in the UK, we have this thing called the AI sector deal. It's a $1 billion package for boosting AI, the boosting of AI industry. They often seem to be focused on big initiatives like flagship academic research institutes or like moonshot projects. And it struck me that this is kind of at odds with advice that I've heard you give before, which is with AI, it's best to just start small, do some tinkering, get something working, get something moving, and then start to build on it. What would be your what would you think about this in terms of public policy? Should the government, like the UK government, be going for these big moonshot projects, or they should be trying to foster this tinkering kind of approach?
Yeah, I think both are worth going for. Most countries are probably underinvesting in AI. Maybe, and I see this quite clearly in the United States, where these brilliant scientists, they become professors at universities, and then they spend ridiculous amounts of time writing funding proposal after funding proposal, many of which are rejected. So some of the most brilliant researchers spending way too many hours of their life writing proposals we do need accountability. I'm not saying anyone should get funding for anything, but I think it's a proportion of really smart people's time spent trying to raise money for the research groups is very clear that the process is not efficient in the United States. And so I hope that when you have brilliant researchers working in academia or corporations, that the money from the public, right? We do need accountability and fair process, but I think greater allocation toward educational research would serve most countries well. And then I think that there's a role for moonshot projects, and there's also a role to empower lots of bottom-up tinkering. What I think many people underappreciate is the educational impact that bottom-up tinkering has. So it's actually okay if someone does a small project, publishes a paper. Maybe it doesn't change the world right away, but that person is now smarter at whatever they just spent time tinkering at, and then they can then do the next bigger project and the next bigger project. So I think that we tend to underestimate that impact. And then I think thoughtful moonshot projects is a good thing too. I think the challenge is, how do you pick the appropriate moonshot projects, which requires both the technical judgment about what's plausible, as well as sort of the judgment for whether this will have the impact that you want. And then I think funding those projects, it can work well if you have the right leadership to choose the right projects and put in place the right structures.
Great, thank you. Okay, so I'm going to switch to QA from the audience. And Jim, I think, is going to be feeding us some of the questions. I see lots of questions coming in. I'm going to just start off with one from Christine Foster in the audience, who is the CCO of the Alan Turing Institute. Christine is asking, how might the UK carve its own path in the field of AI, with both the US and China being so dominant? And in particular, if Andrew sat on the UK's AI Council as an independent expert, what advice would he give governments on deploying, on developing the AI industry in the UK?
Yeah, thank you, Christine. It's great to see you here. Maybe a couple thoughts. I think right now there are two, and there could be three major powers in AI. US is one, China is one, and then I think Europe would be the third. Follow Brexit closely. We all know what happened there. But I think Europe collectively would be a very strong third force. I don't know if, maybe a couple thoughts. I think that, I think the UK should do things that complement UK local industry. So for example, actually some national governments have actually asked me if I thought they should build their own web search engine. And I usually say no. That was the competition from 10 years ago. There were web search engines that work pretty well. I do think governments should regulate them properly, right? We've seen social media companies in the US, shut down Donald Trump's accounts. And when social media company can do that to the president of the United States, it does raise obvious questions about, what will happen to his estate or others leaders in other countries as well. So I think well-run democratic countries should make sure to demand the transparency and to regulate the domestic and the foreign tech companies operating within their borders. And I do find that, unfortunately, regulators are sufficiently far behind what goes on in the tech world. So when I read news about what policymakers are talking about now in terms of the impacts of AI, I was in private conversations 5 or more years ago about some of those impacts that the tech companies already understood. Like so regulators are 5 years behind the tech world. I think that makes regulation difficult. So I think regulating what happens within your own borders seems like an important piece of it. And then I think also, if you pick UK industries that AI can support, I think that's when the UK will have unique advantages that so some projects are harder to do from Silicon Valley than from the UK. And I think also taking the initiatives to build the next generation rather than competing from the competition that we had 10 years ago would help us build more toward the future.
Thank you. Okay, so we've got loads of questions from the audience. We've only got 5 minutes left, so let's go through them as quickly. So we've got David Sharp asking, please can you say something about autonomous vehicles? When do you think AI will be smart enough to drive them safely?
Hard to say. I think I don't know. They have I know there's a lot of this in the news. Really impressed by what Waymo has done in Phoenix. I think that in constrained environments, in relatively constrained environments, we are quite close. So if you can constrain the environments just a bit, I think we're quite close. But to drive in complex, chaotic cities, right? To drive around in downtown London with all the chaos in the great metropolitan cities of the world, that still seems very challenging. So I think that this is one interesting thing that's happening in China as well. In China, if a local government helps self-driving car company modestly constrain the environment, just let's rip out a few trees, and that doesn't sound very friendly, but re-engineer a few roads, right, to help engineer some of the corner cases away. I think that actually makes it much easier for self-driving to be practical. So I think in constrained environments, we are very close. But in completely unconstrained, arbitrary environments, driving in downtown New York City or driving in downtown London, that still seems difficult to do safely if we have other people and drivers behave exactly the way that they're behaving today.
Okay, so let's move on to a question from Rich Pugh. How do we ensure advances in AI and machine benefit society as a whole, as opposed to only increasing commercial profit margins?
I think that government regulations. So I think there are multiple things we need to do. I would love to see multiple countries have government leaders that are well educated or reasonably have a good enough understanding of AI, what it can and cannot do, what are its impacts, so they can pass appropriate regulations to help ensure that on average, AI is used to benefit society as a whole. And for what it's worth, for all of the ills of capitalism, I think capitalism has been, on average, a pretty good force for lifting a lot of people up. It has clearly created some really bad things as well, right? Addictive digital products, biased things. So clearly capitalism has had this no significant ill impact. But on average, over the arc of history, I think capitalism has been a helpful force. So I think letting companies build successful products on average creates some ills, but so I think if government regulators can empower companies to act, but try to regulate out some of the societal ills that we're all maybe unfortunately more and more aware of, that might be a reasonable path forward. And there is actually one other effect I want to comment on that's not widely understood, which is AI is increasing concentration of power like never before. And I think we need government regulators to take a careful look at that and figure out what to do. We've all seen that tech tends to have winner-take-most or winner-take-all dynamics, right? So, what is the 5th most valuable web search engine? I mean, do you even know? What is the 5th most valuable social media company, right? So in a lot of in tech, in most vertical examples, there's a small number of companies that, has consolidated a lot of the influence and power and user base, because the internet lets you centralize data from around the world. AI lets you process the data. And so the dominant players may become even more dominant. What not many people realize is that this winner-take-most, winner-take-all dynamics is not true only for traditional tech industries these days. So take retail. Retail wasn't traditionally wasn't traditional tech industry, but Amazon now is a tremendous force in retail. Or take transportation. Transportation wasn't traditionally a tech industry, but look at what Uber and Lyft have done to the taxi industry. And I think over the next decade, we'll continue to see this consolidation across agriculture, healthcare, manufacturing, logistics, where the pattern is in all of these industries, the internet lets these players collect data from around the world. AI lets them process this data. And so there is a small handful, maybe more than one, but maybe a very small number of companies that will be very dominant in a lot of industries that are not traditionally considered tech industries as well. So how do we operate in a world where almost every industry is a natural monopoly? And also what happens if in the UK, the natural monopoly for a lot of these countries is not a UK company? Or then how do we make sure there's a balance of interest between the UK and other countries? So this concentration of power in all industries, because tech has now affected, right? We're now in every industry is a tech industry. So how to build society around this, I think, is a significant challenge. I don't have a good solution to this. I think a lot about it. Maybe, hopefully, someone smarter than me with an idea. But this is one thing that I hope governmental bodies and international bodies can get around the table to design a solution to.
Andrew, we're over time, but do you have time to answer a couple more questions?
Yes, I'm okay. But really, thanks everyone for all the
time?
questions. I'm sorry we couldn't answer all the questions. It's nice of everyone to spend the time with us here and ask all of these questions.
There are so many questions. I didn't realize. So do you mind if we ask just a few more questions?
Yeah.
Just let us know when you need to go.
I would love to.
So we have Dat left now.
Yes,
great. We have Dat left now because he's asking. Sorry, say again?
Yes, I'm good for time, so please go for it.
Oh, great. Thank you. So Detlef is, where do you see the future of deep learning going? Do you expect to see the end of backprop and new types of learning algorithms? And how important is explainability in the context of deep learning?
You know, we all would love to come up with something better than backprop. It's one of those things. We don't have a better idea than backprop right now. But if someone comes with a better idea, then we all be surprised at how quickly some new thing takes over. I think it's a great research topic because there are different learning principles than gradient descent that works as well, even better. Don't know. It's a fascinating research topic. Hopefully, definitely encourage researchers to work on it. It's also quite possible that we'll keep on using backprop, but also have a new learning principle, and then we just have multiple algorithms. One thing about AI is machine learning has become complex enough. It's not one size fits all, right? Sometimes you use linear regression, sometimes you use logistic regression, sometimes you use a convolutional neural network, sometimes you use an LSTM, sometimes you use transformer network. So maybe sometimes you use backprop and sometimes you use something new to be invented. Yeah. Sorry, what was the second part of that question again?
The second part was about explainability in the context of deep learning.
Oh, yes, I do think it's very important. So I know that there's one point of view which I don't agree with, which is if it does want a test set, why do you care about explanations? So I've heard that argument, but I don't buy it. And the reason is for a lot of the things we need to do, doing well on the test set is not enough. So actually earlier this morning, I was writing a letter in The Batch. We have a weekly newsletter called The Batch that goes there every Wednesday. So I was actually literally working on a short piece 2 hours ago. It'll be sent out in a few hours on exactly this problem, which is over the last few decades, we collectively, our community, has gotten really good at doing well on the test set. That's how you publish a paper, and it's great progress. We should celebrate this. Unfortunately, for a lot of practical problems, the fact that we do well on the test set is not enough, right? Because of concept drift or data drift. Or because even if you do well on average test set error, you may do poorly on a important subset of examples. Actually, one system my Stanford team built, we're diagnosing medical images from X-ray, and so we found that because a small fraction of patients have hernia, we could basically ignore hernia diagnoses and still do fine on average test set error. But if more hernia patients come in and we just completely ignore the fact that they clearly have hernia, that's clearly not acceptable from a diagnostic point of view. But so I find that because we're pretty good at doing well on average tested error, but that's not enough. So I find that visualizations, transparency can help people help spot the problems in our system so that we can make it do better. And then in addition, there's also been this debate about should we build AI or IA, artificial intelligence automation or intelligence augmentation. And sometimes it's framed as a philosophical or moral debate. Should we, automate things or should we help humans? And I acknowledge that the philosophical and ethical debate is important and making sure people have jobs, right? That's super important. And I find that there's also a very practical, technical aspect as well, which is for a lot of problems, I don't know how to build an AI system that works well enough without people to work side by side with the AI. And if that's the case, then the visualization can be really important because it's just a fact. The philosophical and ethical things are important, and even independently of that, there are medical diagnosis settings where a human and an AI will just factually do better than either in isolation. And there are some cases where AI does better and doesn't need the human's help. I've seen that too. And I think that needs to be an important criteria for deciding what to do as well, for what system to build and deploy as well.
Fantastic. Well, thanks so much. I know we're over time. Andrew, thanks so much for coming to talk to us. We all really appreciate it. Thanks everyone for all the questions and for participating. Yeah, thanks once again, Andrew. And to everyone in the audience, please sign up to the data science section to hear more about our future events. Thanks once again, Andrew. Really great talking to you.
It's a real thrill to speak with all of you at the RSS. Here in the United States, we have nothing royal. And so when I was a grad student growing up, I always had this very high esteem for the RSS and wish that I could be a part of it. So I was really thrilled when I was invited to speak here. So thank you, Sylvia, Martin, and everyone.
Yes, we're absolutely delighted. Thank you very much for taking your time. And I'm sure that we will, there were 60 questions in the thing. So we will try to convey the interest about all these questions to you.
Thank you.
Thanks so much. See you. Bye-bye.
And thank you, Martin and James and Filippo for the perfect organization.
Take care, everyone. Thanks again, Andrew. Bye-bye.